This is the ostrich. As you can see, there are many features that make the ostrich unique from other birds. For starters, the ostrich is actually the world's largest bird. It can grow up to 9 feet tall and weigh up to 320 pounds. Unlike most other birds, the ostrich is flightless. However, it makes up for its inability to fly with its capacity to run at fast speeds. An ostrich can reach speeds of 45 miles per hour. Because of these unique characteristics, the muscular system of an ostrich is specially adapted to support its large size and ability for high-speed locomotion. The throat muscles of an ostrich are very important because they allow the bird to endure long periods of thermal panting, also called gular fluttering. Gular fluttering requires rapid, rhythmic contraction and relaxation of throat muscles. Ostriches cannot sweat, so this panting allows the large bird to stay cool.
Ostriches are categorized as a ratite, a flightless large bird with no keel on sternum which prevents flying. A keel would typically be where the muscles of the wings would attach to. This is the pectoralis major, a large prominent breast muscle that originates along the breastbone or sternum and inserts near the humerus. When the breast muscle contracts, it brings the arm close to the body. The muscle underneath the pectoralis is the supracoracoideus. It raises the ring between the wing beats. Pectoralis major and supracoideus are connected to the sternum. This is remarkable because of the other vertebrates they have muscles to raise the upper limbs generally attached to the areas on the back of the spine. Supracoracoideus and the pectoralis major together make up about 25 to 35% of the bird's full body weight. Supracoideus works using like a pulley system to lift the wing, while the pectoralis provides powerful downstroke.
One thing that the ostrich does is feather fluffing. Feather fluffing is when the ostrich contracts its muscles to raise its feathers to increase the airspace next to its skin. An ostrich's wings muscles stretch about 2 meters. Ostriches do not use their wings to fly, but instead use them to maneuver and brake while running at speeds. Ostriches' wings also help them maintain their balance.
We know ostriches are unable to fly, however they are the fastest birds on land, meaning that they can outrun their predators at 40 miles per hour, thus making up for their inability to fly. All the following features help with the ostrich's quick running ability. They have long, lightweight pelvic limb bones, and as shown in the video, the orange string is the well-developed pelvic limb muscles of the ostrich. They have large muscles in the proximal limb as well as long tendons. Additionally, a lever system helps stretch these pelvic limbs with extension of the digit. Ostriches also have their muscle mass located higher in the leg area. They're able to keep the pace at high speeds because they swing their legs faster with little effort. However, the disadvantage of less muscle mass in the lower leg means that there is no flexibility of side-to-side motion. However, this can also be an advantage because energy is not wasted for the side-to-side motion.
The ostrich's musculoskeletal structure and pelvic limb musculature is much better adapted for running locomotion than humans. The extensor muscles shorten in order to accelerate the body. While walking, the ostrich femoral excursions are minimal, but extension at the hip does increase during high-speed locomotion. The large hip extensors shown here are able to generate high powers. Also, ankle extensor muscles play a large part in propulsion, as extension of the ankle lengthens the leg and acts to propel the center of mass up and forwards. Of all flightless birds, the ostrich has the longest legs relative to its size and has the longest step length when running at 5 meters. As we talked about earlier, the majority of its leg musculature is located very high on the thigh bone, as you can see here, and hip, as opposed to the lower swinging elements of its leg, which are comparatively light and are moved by long, mass-reducing tendons. This arrangement of its leg optimizes the ostrich for high-velocity locomotion, giving it both a long step length and a high step frequency.